Hi, and welcome back to Miss Riley's Maths videos. This is a video for my Leaving Cert Ordinary Level students, and I'm choosing to do a video on this graphs of functions and graphs and whatever because it's a big part of the paper one, and it does seem to scare people and they get a bit stressed about it. So um, I am going to work through these questions um, from the past papers. I've picked out a few past paper questions. I'm going to work them through. So there are about 4 or 5 questions on this. So feel free to scooch through the video until you find the question that you're looking for. Just before I start, I have got some notes. I'm just going to um, show you these notes before you start. So just some tips about how to go about answering these questions. So making sure you read through the paragraph at the start, looking at the graph itself, what are the labels on the axes, what are the units, what's the title, what kind of shape does it have? You know, is it a quadratic or a linear or an exponential or a cubic? And answering questions on the graph, remembering the connections to differentiation, you know, so that if it's increasing, that means the function's increasing. That means it's uphill going from left to right. It means it's got a positive slope and dy dx is greater than 0. It's positive. If it's decreasing, as in the function's decreasing, it's got a downhill slope from left to right. It's negative slope. And it means that dy dx is less than 0. And the other connection to differentiation is the one in terms of maximum and minimum. And remember that the maximum point of a graph refers to the top of the graph and the minimum point there, and the minimum point refers to the bottom of the graph. Now the graph may go like that, or the graph may go like that. You know, there might be other points, but they're talking really about the peak and the trough. And remember, you might be asked for the coordinates or just the y value or just the x value, so just be careful on that. And remember, always at those points, the slope is 0, so dy dx is 0. Okay, anyway, I'll leave you to read those at your leisure, and I'm going to go straight to 2023, question 9 on paper 1. So the diagram below shows the actual number of new cases of a disease from day t equals 0. So there's the day, look on the x-axis, to day t equals 25. So what they're telling me here is that I'm going for 0 to 25 on the x-axis, and that's the number of days. And then on the y-axis, it also shows the number of cases according to a mathematical model over this period of time. So here's the number of cases. So these numbers here on the y-axis are the number of cases. So for instance, you can see on 1,000 new cases, 1,000 cases, 2,000 new cases, 3,000 new cases, and so on. Now the straight line, this is a bit, or the black line, this is a bit different to normal. I haven't seen one like this before. They're giving you two things. They're giving you what they're expecting it. That's what they mean by modeling the number of cases. If they expected, you know, what would you expect to happen? This is the kind of mathematical curve that they've put on all these cases. So I'm not sure whether they found the number of cases and then did a line of best fit, or whether they had this black line and then they put in their cases. Anyway, hopefully we don't need to worry too much about their methodology. So anyway, number of cases, number of days, and basically each dot matches somewhere. So like day 1, this must be day 1, mustn't it? This must be day 2, day 3, day 4, and so on. Okay, from the diagram, estimate the number of actual new cases there were on day 12 using the relevant dots. So day 12, so there's 15 and 10, so that must be 11, that must be 12, that must be 13, and that must be 14. So I'm going to use my ruler. Day 12, well, there's day 12. The actual number means looking at the dot. So I'm going to go across from the dot. And remember, always show your work on your graph. Going across from the dot, it looks to me like it's halfway between 1,000 and 2,000. So it looks to me like it's 1,500. So I'm going to put 1,500 new cases for that day. Okay, so 15. I'm just going to write new cases there so I know what I'm talking about. So what did I do there? I looked for 12 on the x-axis. So 12 on the x-axis. And then I went up from 12 and across to the y-axis. According to the model, which is the curve, so not the dots. So not the dots. There were 1,000 new cases on day 12, t equals 12. So they're actually saying there, actually, there was 1,000 new cases. Look across from there. That makes sense, yeah, fair enough. Work out the percentage error in the model's value for t. So that's percentage error. Remember, percentage error is more arithmetic. So percentage error is going to be the true value minus the estimate. Yeah. I'm going to work that out first, and then I'm going to put that's going to be my error. And I'm going to put my error over my true value times 100. So let's get our values. We did the true. So the true is the dot. The true value was 1,500. The curve is the estimate. So the estimate, which is the curve, the line, is 1,000. So the error is equal to 1,500 minus 1,000, which is equal to 500, is the error. So the percentage error is equal to 500. I'm using this formula here. 500 over the true value, which is 1,500 times 100. And when you put that in your calculator, you'll get 33.33%. So they're looking at to the nearest percent, so 33% is the error. Okay, so that's kind of a bit nasty throwing that in, but hopefully you know about percentage error. It does come up quite a lot actually, so keep an eye out for it. Next question. Show that it takes approximately 5 days for the daily number of cases to double, according to the model. That's according to the curve. So again, what I'm going to do is I'm going to tear my handout here so we can look at it. So here's my approximately 5 days for the daily number. Okay, so we've got to look 5 days. Suppose we could do this 5 days or this 5 days. So let's look and see. So day 0, there are maybe 200 cases. Day 5 is, let's see, if I draw across from there, day 5 is there. Now, let's just see, can I use this? It doesn't, well, it's almost exactly, yeah. So actually sorry, I didn't do that on the thing. So what I did was I went to day 0, which was, I reckon, 200 cases. And day 5 is here, I reckon it's 400 cases. Well, that's what I'm going to say. So 400 cases. So 200 multiplied by 2 is equal to 400 cases. Now let's just check, which is day 5. Let's just check, did it happen before that? So day 4, no, was not at 400. So I think we can say it took till day 5. I think that's enough. If we want to, we can say day 4 is equal to maximum, I'd say 300 cases. So it took until day 5 for that to double. Okay. Hence, oh dear, that means they wanted to use this one here. Estimate on what day, so what value of t, the number of new cases will first be at least 100,000. So they want to find out what day 100,000 cases. And this is according to the model. So the model means the line. So looking at the line, so we need to know if it's going to double in 5 days, because that's what they're saying hence for. Hence means use what you just did. Okay. We need to know it's going to double in 5 days. So we want to know, when is it 500,000? Sorry, 50,000. Because 100,000 doubling means that 100,000 divided by 2 would have to be 50,000 because 50,000 doubled is 100,000. So when is it 50,000? Is it 100,000? Yeah. So let's see, it takes 5 days to double. So let's see, we have on day 25, we have about 63,000 or 64,000. What do you reckon? I think 64,000, say. So on day 25, so day 25 will be 64,000 cases. So in 5 days, so day 30, there'll be 128,000 cases because it'll have doubled in 5 days. Day 35, let's just show what I did there. Will be 128,000 times 2, which is 256,000 on day 35. Let's double it again. Day 40 will be 256,000 by 2, which is 512,000. And then, so by day 45, it'll be 100,000. So 124,000. So I think that we can say that on day 45. Oh, sorry, be at least 100. I was going at least 100,000. So 64,000 on day 25, 128,000. So I actually went too far, didn't I? Didn't need to go on there. It's 100,000. I was thinking it was 1 million. So 100,000. So day 25 is 64,000 and day 30 is 128,000. So it's somewhere between these two. So maybe let's look and see, well, if it's 100,000, then it's got to be 50,000 before that, like I said here. So 50,000, and then divide by that by 2 again will be 25,000. Still don't have 25,000 here. And then divided by 2 again will be 12,500. Don't have that again here. Divide by 2 again will be 6,250. So let's find out, is there one that's 6,250? No, so it is, it's 25. Day 25.